Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice algebra problem, and here we have 3 to the power of n plus n is equals to 30, and we will solve this problem for the values of n. So the very first thing we are going to do is, here first I can introduce a little bit a Lambert W function. So I can solve this problem by using this function, and it is known as Lambert W function. And the Lambert W function is stated as, if we have w of a to the power of e to the power of a, if you can multiply the exponent of e by itself, then it is equals to a. If you have some terms like w of a into e to the power of a, so it will be equals to a. So now we can use this nice function in our given question, and we can find the value of n. So that now first I can convert this statement into the Lambert W form, so that the very first thing we are going to do is, here first I can move this 30 in the or we can just move n in the right hand side, and here you obtain 30 minus n is equals to 3 to the power of n. And after this step we will divide both sides by 3 to the power of n. So here you divide both sides by 3 to the power of n, and this will becomes 30 minus n over 3 to the power of n, and this whole is equals to 1. After this step we can move this 3 to the power of n in the upside, and it will be written in the form of 30 minus n times of 3 to the power of minus n, and in the right hand side we have only 1, because here according to the exponential law, we will say that if you have 1 over a to the power of n, it is equals to a to the power of minus n. We can apply here this nice exponential law in this term, and after that we can just write here, or multiply both of the sides by 3 to the power of 30. So when you can multiply both sides by 3 to the power of 30, then it will becomes in the form of 1 multiplied by 3 to the power of 30. And now in the left hand side you see that we have bases on both of the terms are same, so that its exponents are added, and we got here 30 minus n times of 3 to the power of 30 minus n, and this whole is equals to 3 to the power of 30. And after this step I can use here an important property of logarithm, and here you see that we have e to the power of log of a is equals to a, because here you see that this e and natural log are cancelled each other, and you get simply a. And now we can write here the term 3 to the power of 30 minus n as 30 minus n times of e to the power of log of 3 to the power of 30 minus n, and this whole is equals to 3 to the power of 30. Here I can just take the log and anti-log at the same time on the term of 3 to the power of 30 minus n. So after this step we can apply the property of logarithm, and you can write 30 minus n to the power times of, here you can apply the natural log property, and we move this exponent in the front of this log, and you write 30 minus n times of log 3, and this whole is equals to 3 to the power of 30. And in the next step I can just multiply both sides by log of 3. And when you can multiply both sides by log 3, then you obtain 30 minus n times of log 3 into e to the power of 30 minus n times of log 3, and this whole is equals to 3 to the power of 30 into log 3. And after this step I can just apply here the Lambert W function on both of the sides, so that you can apply this W on both of the sides and you get 30 minus n times of log 3 into e to the power of 30 minus n times of log 3, and this will be closed, and in the right hand side you have w times of 3 to the power of 30 into log 3. And now I can apply here the Lambert W function, and in the start of the question I can explain the Lambert W function, and which can be written as w of a to the power of ea, then it is equals to a. So this is the Lambert W function. I can apply this Lambert W function on the left hand side of this equation, because here you see that this is the value of a and this is the value of again a. So here this equation will be in the form of Lambert W function. So the output of this function will be equals to 30 minus n times of log 3, and its whole is equals to, in the right hand side we have w of 3 to the power of 30 times of log 3, and we can write 3 to the power of 30 as 3 to the power of 3 plus 27 into log 3. And now we can break this exponent of the right hand side, and you can just get here w of 3 to the power of 3 into, here you get log 3 times, here you obtain 3 to the power of 27. And now you know that here 3 to the power of 3 will be equals to 27 times of log 3, and here you have 3 to the power of 27, and we can take the log and anti-log on this term, so you get e to the power of log 3 to the power of 27. And now you can apply the property of logarithm on this term, and you obtain 27 times of log 3 into e to the power of 27 times of log 3. We move this exponent in the front of this log, and here you see that we will again write here this Lambert W function. So we can apply the definition of this function, and you obtain here 27 times of log 3, and in the left hand side we have 30 minus n into log 3, and here you see that this log 3 are cancelled out by this one, and here you obtain 30 minus n is equals to 27, and here we move 27 in the left hand side and n to the right hand side. So finally you get the value of n is equals to 3. So this is our final answer of this question, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.